The graphs in 11c, D, and E are not as precise as what we had in A and B because they're not our parent functions. What we have are C and D, they're in factored form. We're going to use our ideas of multiplicity, factored form, and leading coefficients to help us graph. And in E, we just have to factor first. So let's tackle C. What we see is this is already in factored form, and since it's in factored form, it makes it relatively simple to graph the general shape. So if x is a factor, then 0 is one of our x-intercepts, and if x minus 3 is a factor, then 3 is our x-intercept. But there's a multiplicity of 2 there, so I got to pay attention to that. And the other thing I want to make sure is I pay attention to my negative sign, because it's negative, it tells me something about the end behavior. And the overall degree of this, if we have an x to the first times x to the second, this is a third-degree polynomial, so it's telling me the shape. Because it's negative, it's going to start high and finish low. So I had that general idea in my head. And I know I need multiplicity of 2 at 3. So this multiplicity means it has to be tangent to the axis. So it's going to start high and then come down low. So I'm starting high, coming through the 0. Then it's going to come back up, but it's got to be tangent at 3 and then finish in the opposite direction because it's odd. So odd has that opposite end behavior, so that is what this graph could resemble, the shape of that. Like I said, these aren't nearly as precision-based, but what we want to do is see the general shape. Knowing the behavior at each individual 0, this one looks like a line, this one has to look like a parabola because of the squared and the 1. And it's got to go high to low because of the negative, and it's a third-degree polynomial. So a lot of little pieces of the puzzle that help us create this sketch.